Hi, I'm going to show you how to do partial fraction decomposition. What even is it though? So partial fraction decomposition is when instead of going from 2 or 3 or 5 different fractions, combining them into one, you do the opposite. So you have one fraction and you're trying to break it into different parts. So let's try an easy example. So let's say we're adding two fractions together. 1 over x plus 2, and most of these will have variables, so that plus 3 over 2x minus 3. So we can solve that. We know how to do that. It's just we want the same denominator in both of them, and then we can just add. So let's do that really quickly. So that is what we have as a result. So let's say we didn't know about this and we just wanted to go back. So we know for sure that it would be in this form. It would be a over something plus b over something. What that something is, we can figure out right now. So that something is actually the factored terms of the denominator. So in this case, it would be, let's factor this really quickly again. So once you've factored this, one of the factors will be here and one will be here. And it doesn't matter which one is which. So I'll just put this one here and this one here. So 2x minus 3 and x plus 2. And if you don't understand it now, it's fine. Because it took me like a week to understand this, so right now you can just follow the formula, and then once you do a few of them yourself, you'll understand it eventually. So if you don't understand it yet, it's fine, just keep listening and keep thinking about it. But it makes sense, right? Because whenever we wanted to combine the two fractions, we multiplied it by, so we would get the same denominator. So it would be like a bigger one with these two combined. So here we want to do the opposite, so we factor them out and assign them to each of these fractions. But what are our two variables? What are they equal to? So here is where we need to think, we need to use our big brains a little bit, okay? The logical thing to do is to solve this as an equation. So first we multiply this side by the denominator here. So we multiply both of these by 2x minus 3 and x plus 2. And this one also, 2x minus 3 times x plus 2. We would get 5x plus 3 on this side, and since these would cancel out, on this side this would be all. But on this side, we can cancel out the 2x minus 3 here, because it would be 2x minus 3 times a over 2x minus 3, so we can cancel those out. So we would get a times just x plus 2. And the same on this side. So plus b times 2x minus 3. Because the x plus 2 would cancel out. So we would only get this. So now we can rewrite this side again. And we can multiply all of this out. And this is our result. So now here's the trick. We want to get this kind of formation on this side. So we want something times x plus a number without x, or in this case we would have variables. So here we go. 5x plus 3, this is the same, equals, and now look, we can factor out the x. So if you just look at ax plus 2bx, we can multiply the x out, so we can get a plus 2b, don't forget the 2 here, and close parentheses, times x. So if we multiply it back out, it would be ax plus 2bx. So we didn't change anything, these are equal, but we just came a little closer to this step. And now we can just rewrite this part plus 2a minus 3b. So we have something times x plus something, two numbers without the x. And if I color code this a little bit, then maybe you will understand that this is equal to this. If we just put this into parentheses, like this, so like 1 times 2a and 1 times negative 3b, it would still be the same, but there's like a little 1 here, and there's a little 1 here. So now these parts also become equal. And guess what? We can rewrite it like this. 5 equals a plus 2b, and 3 from here equals 2a minus 3b. And now we have two variables that we don't know and two equations. So now we can solve for both a and b and get our fractions, get our answer here. So let's do that really quickly.
And minus 10, I'm just multiplying this row by 2, equals 2a plus 4b. And that is equal to, I'll write it over here, negative 7 equals, these are crossed out, and then this is b. So then we go to negative, and that's negative 7b.
So b equals 1. b equals 1, and from here we can find a. So a plus 2b, so plus 2, because b is 1. And 5 minus 2 is 3, so a equals 3. So here is our answer. Well, it's not actually our answer, but now we can check. So let's rewrite the whole fraction. What was our form? So we had a over 2x minus 3. So a is 3. 3 over 2x minus 3. And then plus. And we have b here over x plus 2. So b is 1. 1 over 2x, no 2's. X plus 2. Forget about that 2. And look at this side. They are the same, except this one is switched, so they're just in different order, but they're still equal. So we can put a big equal sign here, and that means we did it right. So we pretended like we didn't know the answer, and we went from here, to this form, to getting two equations, to getting these two equations, and solving them, and plugging the variables in here. Well, let's try a different one. Let's get a very complicated fraction. So both the numerator and the denominator will have polynomials, or x to the big power. So x to the 4th power plus x squared plus 1 over x squared times x squared plus 4 squared, all squared. And this is a fraction that we need to decompose now. So as we see, the denominator is completely factored because we can't factor x squared plus 4. And we obviously can't factor the x. So this is completely factored, and the numerator, well, we'll just forget about the numerator for now. So now, let's do the same thing we did on the other example. So let's write out all the fractions in letters. So let's do the same thing. We have a here, and our first term would be x, not x squared, just x. And then we would have plus b, right? Now here, it gets a little more tricky. Because if we just put another x here, because this is technically x times x, but we can't just put x here. It needs to be x squared. And it needs to be x squared because if this was just x, this would also be just x. Because the biggest power of x in the denominator in the original fraction, the sum of the fractions, would only reach up to x. So this would obviously also be x because we would have a plus b over x. But we need to have x squared here because it's the bigger term here. So if we had, for example, x to the third in here, we would also have x here, x squared here, and then x to the third here. So we don't ever repeat the x to the first power. So let's keep going now. We have two of these terms, right? So the denominator, we know for sure, will be x squared plus 4. And then we know from this logic, the second denominator will be x squared plus 4 all squared. Because it's the exact same thing as here, except we have a 4 in the equation. What would the numerator be though? This whole thing cannot be factored because if this was a minus, it would be x plus 2 times x minus 2. But in this case, we can't factor it. Because of this, we have to introduce two new variables and an x here too. So we would have c x plus d. So we would also have a plus here and an x here. And the exact same thing goes for this one. So we would, except we would use new variables. So we would have e x plus f. So this is our new, more complicated equation of what this fraction would be like decomposed. But we're not going to solve it because there's 1, 2, 3, 4, 5, 6. There's 6 variables here. So you can solve it on your own time and then you can check to see if you get this. But I'm not going to do this. So let's try a similar example but with fewer variables. So here's our new example. So we have a completely factored denominator and 2 factors and a kind of complicated numerator that's kind of ugly, honestly. So let's do the same thing we did for the other ones and write variables on top of the whatever fraction we're going to get. So we know for sure that the denominator would be these 2 factors. So x squared plus x plus 2 plus something over x squared plus 1. And notice how we have the same thing we did in the previous example, where we have an x squared plus something here. X squared plus something in both of them. So we would do the same thing where we would have a and an x in the numerator plus b. And this one with different variables, cx plus d. So this will be our form once we're done. We just need to solve for a, b, c, and d. Only 4 variables this time instead of 6. So let's do that. So remember how in the first example we multiplied this side by the denominator on this side. So let's do that here too. So we would have a x plus b, and these ones would cancel out, so we would only be left with this one, so times x squared plus 1. And now for the cx plus d, we have the opposite ones. These cancel out, and we have this one left, so x squared plus x plus 2. So this is what we have to work with here. And that is, of course, equal to 2x to the third, our numerator, 2x to the third plus 7x plus 5. Okay, so now we just have to factor all of this out and get the x's, the x squared, and the x and the 1's all together. So we would have ax to the third plus ax plus bx squared plus b plus cx to the third plus cx squared plus 2cx. And make sure you're doing this with me, so you catch any of my mistakes if I make any. Let's hope I don't. Plus dx squared plus dx plus 2d. Phew, okay, that's a long equation. But now we just need to get all of the x to the third, x to the squared, x, and 1's factored out. So let's start with the biggest ones. Ax to the third. X to the third we factor out. So we would get a plus, what else has x to the third? C. I crossed them out just so I can keep track. So a plus c, x to the third. That's all. So now we go down to x squared. So plus b plus c plus d. D also has x squared. Plus d x squared plus just x's now. So a plus, not b, 2c, don't forget the 2 here, oops, 2c plus d, all times x, and now we can just have like a 1 here, 1 times b and 2d, b plus 2d. Okay, it's still very long, but at least it looks a little more organized now. So we have this part, this part, this part, and this part. And guess what? They're all equal to this. The 0, there's a 0x squared here. So this would be 0. And then 7, and then the 5 here. So now, guess what we do? We make equations again, and we're going to have 4 different equations with 4 variables. So, a plus c equals 2. B plus c plus d equals 0x squared. A plus 2c plus d is 7. And b plus 2d is 5. So, once we solve for all these variables, we're going to have the answer here that we can write as a fraction. So the best way I think to solve this one here is by the elimination. I encourage you to do this by yourself right now. Pause the video and do it, and I'll do it really quickly too. Alright, so just with a little bit of work, I found that negative b equals 5. So b equals negative 5. And then I plugged them into different equations here, and I found all the other letters. May have messed up here, but I found all the other letters. Now, all we need to do is plug them in here, for which I need a new piece of paper. Alright, so now we just plug everything in, and we'll be done. So, a is 2ax, 2x plus, and b is negative 5, so plus negative 5, or just minus 5, all over x squared plus x plus 2, x squared plus x plus 2, plus c is 0, so no c's, plus d, so 5 over x squared plus 1, And we're done. This is our final, this is our final answer. All that for figuring out what numbers to add to get this. This is the basics of partial fraction decomposition. I hope you understood it. I hope that you'll try some examples on your own and maybe let your brain have some time to work on it and think for itself, I guess. And I'll see you next time. Bye!